Hello and welcome to our presentation on the customer lifetime value prediction for Google's official merchandise store. And we are Team Sales. Now let's take a preview of our presentation by looking at some of the most important numbers. Our XGBoost model's MAE is 59% lower than the naive MAE. The XGBoost model has the lowest MAE at 12.57 in the holdout dataset. And then using a confusion matrix, we can decrease the marketing cost by 7% by identifying customers who have no future revenue. From the Google Analytics sample dataset, we queried data of customers who had their first purchase before May 1st, 2017, and further acquired their first week behavior to make predictions about the future revenue generated from them in 90 days. Therefore, we had the session level data of acquisition within the first week and future purchase. We also separately queried acquisition hit level data since it is stored in nested fields. With about 7,000 observations, there are both numeric and string variables recording the consumption behavior as well as some demographic characteristics of consumers.
To explore the data set, we also need to transform some categorical variables that we are interested in to dummy ones, such as channel grouping, product category, etc. And we recognize that revenue, hits, and page views are stored in the dataset as a sum. To facilitate observation and analysis of data, we divided revenue-related variables by 1 million. With the help of the powerful BigQuery on Google Cloud Platform, we are now ready to carry out a comprehensive exploratory data analysis to the joint session level dataset. Next. Among all the variables chosen, time on site has the highest standard deviation of 915 since it's recorded in seconds. Future revenue also has a high standard deviation of 634 and a mean of 29. That is due to the majority of the values at 0. Similarly, revenue has a high standard deviation of 378 with a mean of 116, which indicates a relatively discrete distribution. Also, we gained some ideas about customer behavior, like 89% of customers are Chrome browsers and 90% of customers use desktop while browsing. To demonstrate the assumption of distribution, we looked into box plots of these continuous dependent variables, which will be presented to you later with outputs in data processing. Lastly, from the heat map, we got the correlations between each pair of variables, just as shown in the right chart. Revenue, visit number, and product quantity purchased that we circled stand out as stronger correlated to future revenue. So the values under these little red circles are 0.59, 0.49, and 0.59 respectively. However, compared with the number of variables input, the correlation between explanatory variables and explained variables is not ideal, which guides us to consider new variables to input. Now, Tim will walk you through the data processing part.
After exploring and understanding our data set, we conducted data cleaning to make sure there aren't any duplicated or missing observations. To improve the prediction accuracy of our models, we also created 4 variables, as we thought these are highly relevant to consumer future purchase intention in terms of business sense. Specifically, frequency refers to the number of times a consumer completed a purchase within 90 days. Purchase interval hour means the hours between the first and second purchase. By weekend is a dummy variable indicating whether the purchase was made on the weekend. And hit check steps shows that how many times the consumer hit the checkout step. Next. As shown in the scatter plots, we saw that some of our observation values are unreasonably away from the main data group. For instance, you can see that for future revenue and purchase quantity, outliers can easily deviate and influence linearity, which might affect the accuracy of our models. Next. In order to be statistically significant, We then drop the outliers by manually posing the threshold for a variable selected in consideration of keeping some outliers for data integrity. Next. Moving forward, looking at our data distribution through the histograms, some continuous variables are extremely right-skewed. Next. So to solve this issue, we perform log transformation to improve our data set for a bell-shaped distribution. Taking the variable of revenue as an example, you can see that our data has been transformed into a much normal distribution. Next, we will have Ling present our model training and key findings.
In the model training part, we split the data into 80% trained data and 20% test data, and we set the random state at 1, 2, 3. We perform 4 regression models. The first one is Lasso regression model. We set the penalty, which is lambda value, at 0.99 by cross validation. The second one is decision tree regression model. We set hyperparameter max depth at 3. The third one is random forest regression model. For this model, we set 2 hyperparameter, which one is max depth, which is set to 5, and the other is 30 for an estimator. The last one is XGBoost. We set the same hyperparameter as random forest. Also, we tried 3 classification model, which are logistic model, random forest model, and SVM model. Out of all possible parameter value we tried, these hyperparameters of each model gain the best performance and efficiency. Next. According to the result, we find that both random forest and XGBoost model have better performance than other. Their R-square is 0.41 and 0.34 respectively. However, the XGBoost model has the lowest MAE 12.57 on the holdout dataset. Also, our XGBoost model's MAE is 59% lower than the naive MAE and 54% lower than the initial XGBoost model. Next. For the XGBoost model, we did a feature importance analysis to find out which variable have more influence on customer lifetime value. Based on the graph, we identified the top 5 features which have a higher coefficient of the model, that are purchase interval by hour, frequency, first week revenue, first week transaction, and hits. Therefore, we assume that the higher value of these 5 variables, the higher customer lifetime value will be. Next. We also tried classification model selection, and we choose logistic model as our best model because it has the highest accuracy, recall score, and precision score. Next is the summary and limitation.
We wanted to start off our summary by getting into some key business insights that we found. First, we were able to decrease the marketing cost by 70% by identifying customers who have no future revenue. Next, high customers with high value can also create higher revenue in the future for Google. And lastly, we were able to come up with 3 solid recommendations for Google. First, by providing sales discounts to first-time customers if they share their first transaction in social media. This will be able to boost more traffic, visibility, referral, and then obviously future revenue. Next, by putting PPC search on Google Merchandise Store, this will then increase hits. And lastly, improving the decision-making process by giving customers discounts within a certain period. This will also increase the sales and future value of customers. And this, for example, giving customers a discount code that only lasts around 72 hours. Next, we want to get into some conclusions. First, we are able to successfully model 4 different regression models and find 4 key important variables. And our best fitting model was the XGBoost with an MAE value of 12.757. And this is 59% lower than the original MAE value. We next want to talk about some limitations and improvements that we saw. Can you get next? First, our log transformation. We experienced some negative coefficients in our log transformation, and we believe this was because customers did not make transactions within the first week. And we saw that there's a bit of a data imbalance because the future value of a lot of respondents of a lot of values was 0, and this made it difficult to train our data. This leads into our time frame. A 7-day period was a little bit too short to predict the future value. And if we had this period to be a little longer, we'd be able to better predict the customer lifetime value and thus improving Google's ads buying platforms such as Search Ad 360. And lastly, the data dictionary was a little bit unclear and some variables were confusing for us to understand. So in the future, we believe that with some better understanding of different variables, we'll be able to have a better analysis and customer lifetime value predictions. And that's all we have for you today. Thank you for listening to our presentation. Are there any questions?